Welcome to Chapter 9, Lesson 2, the substitution method. Okay, last time we learned how to solve a system of equations by graphing. You can always plug in two equations onto a graph, find where they cross or not, or that they're the same, and then you can get the answer. But there are other ways that might be a little bit easier, and the way that we're going to learn in this lesson is called the substitution method. Okay, let's look at an example. Here's a system of equations. X plus y equals 15, and 4x plus 3y equals 38. The first thing we're going to do is solve this equation for y. We're not changing what it means, but we're changing how it looks. So we're going to subtract x from both sides and get y equals 15 minus x. Now that I've isolated y, what does y equal? Well, 15 minus x. So down here, I'm going to take 4x plus 3y. But instead of the letter y, I'm going to put what y equals. 15 minus x. Notice it has to be in parentheses. 4x plus 3, y is equal to 38. Now I can work the parentheses through, collect my x terms, subtract the 45, and now I've got x is equal to negative 7. Now, I know what x is, but in a system of linear equations there is an x and a y. I need to find what the y is, so pick either equation, whichever one is easier. Now, I hope you think that this one's easier with me because that's the one I'm going to use. So I'm going to plug in negative 7 for the x. Negative 7 plus the y is equal to 15. Add 7 to both sides and solve for y. Y equals 22. There it is. X is negative 7, y is 22. So what's the answer? What's the solution set for this system of equations? Negative 7, 22. That's how you do it. And if you plugged negative 7 for x into either one of these, it'll work. And with 22. So negative 7 and 22, negative 7 and 22, both will work. We solved it. Let's do another one. Okay, 2x minus 3y equals 4, and then x plus 4y equals negative 9. Now, the first equation or system that we solved for y. You can solve for x or y. Either variable can be substituted. Since this x is already by itself with a coefficient of 1, let's solve for this. So subtract 4y from both sides, and now we have x equals negative 9 minus 4y. We'll plug it into this first one. Okay, let's do it. So I'm going to have 2 times x, and x is going to be substituted with negative 9 minus 4y minus 3y equals 4. Now, work through the parentheses, distribute, negative 18 minus 8y minus 3y equals 4. Combine my like terms and move the 18 to the other side. So negative 11y is equal to 22. Divide by negative 11, y equals negative 2. So we've got the y. Now come back up here and plug it into this one. It can plug it in anywhere, but since we already solved this one for x, it'll be very easy for us to plug in. So I'm going to rewrite it down here. X equals negative 9 minus 4y. You can see it. Okay, so I'm going to plug in x equals negative 9 minus 4 times negative 2. X equals negative 9 plus 8. X equals negative 1. So what's the solution set? negative 1, negative 2. We got it. Okay, there's two more situations that you need to be aware of, because you may just be jamming along and you'll get to something at the end and it'll confuse you. So let's look at one of those. If you didn't know about it, it'll confuse you, but now you're going to be like, no problem. So here's a system. Solve this one for, let's say this one for x, because that seems the easiest. So plus 4y plus 4y. So now I've got x equals 8 plus 4y, and I'm going to plug it into the first one. So 2 times 8 plus 4y minus 8y equals 6. 16 minus 8y minus 8, plus 8y minus 8y equals 6. So then 8y and negative 8y, combining my like terms, equals 0, so I'm left with 16 equals 6. Wait a minute. This is not true. So there is no solution that will solve this. No matter what I pick for x and for y, I'll always end up with something that's false, which means there are no x-y combinations that make this one work. So if you solve and you get down to the bottom where one number equals a different number, then there is no solution, and these are parallel lines. Okay, another situation. Y divided by 2 equals 2 minus x. 6x plus 3y equals 12. Okay, let's solve this system. Now, you notice this is goofy looking because it's got this divided by 2 business. So let's multiply both sides by 2 to get rid of our fraction. So y equals 4 minus 2x. Now, we already have y isolated, so let's plug it in. 6x plus 3 times 4 minus 2x is equal to 12. 6x plus 12 minus 6x equals 12. Combine like terms, 6x and minus 6x is 0, and we're left with 12 equals 12. This is very similar to the last problem, except now this one's always true. So we have an infinite number of answers. No matter what we plug in for x or y, it will always be true, because 12 is always going to be equal to 12. So these lines are actually the same line. So there's an infinite number of answers. Okay, those are the three situations like we saw in graphing. If the lines are parallel, there is no solution, and you'll get something like 5 equals 3. Never true. If they cross, then there is one answer, and you'll get x equals something and y equals something, as for an ordered pair. If the lines are the same, then you will have an infinite number of answers, and you'll get something like 2 equals 2. Okay? Go ahead and try the problems and let me know if you have any questions.